Welcome to Safety is Everywhere YouTube channel. Dear friends, don't forget to subscribe this channel and share the link with your safety professional friends.
Hello everybody, welcome to today's lecture. Today we will discuss human error identification. We will start with what is human error identification and then we will give you the steps. First one, you require to do task analysis. Then there are several ways to identify human errors. One of the methods is action error mode analysis. Then we will discuss human HAZOP. Then systematic human error reduction and prediction approach, and one case study will be showing you what we have developed. And then I will show you some of the human errors which were studied and developed by Kirwan, given in his book A Practical Guide to Human Reliability Analysis in Appendix II. So, if you recall my last class where we have defined human error and we have given classification of human errors, and also we have identified the causes and brain bottlenecks. So, we discussed about human error in terms of sleeps, lapse, mistakes, in terms of knowledge based, rule based and skill based work and human error. And today we will see more of practical issues, means when you are working in a plant and or you are as an engineer, you want to judge the or you want to identify the human errors. So, those kind of discussions will be made today. Okay. So, human error is well discussed topic. Actually, it is a part of human reliability analysis. So, you will find out that there are many techniques developed in the area of human reliability, and in fact, HAC in 2009 they reviewed 72 potential human reliability analysis tools, and then finally they made a list of 17 tools which are applicable to major hazard condition. In fact, they have given a good review of it, the procedure, the tool, the advantage, disadvantage and the situation under which it will be used. So, now when we talk about human error identification, it is definitely a systematic procedure, and you know the human error is a difficult thing to understand and identify. So, a systematic procedure is required. The procedure comprises primarily these things more or less, and you will find out some additional steps. It all are the varieties only, but otherwise you must do task analysis, then human error analysis, then human error quantification and then human error reduction. Let us see. So, first we will discuss task analysis. This discussion is made, or this PPT is made based on the book A Practical Guide to Human Reliability Analysis written by Kirwan, and this example also taken from his book. Let us see what is task analysis. Its task analysis means you, in order to, when you are doing work, either it is a physical work, cognitive work, whatever may be the type of work, or a mixture of physical and cognitive work. So, ultimately you have certain objectives or goal in mind, and you do that work to achieve that objectives or goal, and in order to achieve the objectives or goal, the work is done in several sequential and or parallel steps. So, task analysis basically it is basically a systematic method. What happened, it basically describe how work is organized in order to meet the goal of the specified task. So, what it does basically, it describe task from its top level goals down to various subtask, subtask to individual operations. Okay. So, for example, you just think of that fill tanker with Cl2 chlorine, that is basically the work or the task that has to be done. Then task analysis, what it will do, it will this is my goal that we want to fill the tanker with Cl2. So, in order to achieve this, what are the things to be done? And that means you have to first plan what is to be done, and then the sequence also of execution also you have to identify, and action to be taken or do the task. So, that is what is task analysis. So, fill tanker with Cl2. Now, in order to fill tanker with Cl2, what are the things you have to do? So, first you are planning, that do in order. In order you have to do first park tanker and check documents, then prepare tanker for filling, then connect Cl2 line and fill up, then uncouple tanker, document and depart. This is in order you have to do. So, that means in order to fill tanker with Cl2, this is the goal, these are the task you have to do. Now, then when you just see that, so let us the second one, prepare tanker for filling. Then again you plan that how do you do it. So, here 2.1, 2.2, 2.3, 2.4, 2.5 it is clearly given, check test valve for Cl2, check WT for tanker, set fill alarm, prepare fill line, connect main Cl2 lines. What is the plan? That 2.1 or 2.2 in either order, or 2.3 to 2.5 in order, means this followed by this or this followed by this, that you can do, but these three in order you have to do. Okay. So, in the again if you see that how this can be done, then again there are subtasks. So, in this manner you will basically decompose or redescribe the task to subtask to the operation level, exact operation level. Okay. So, if you see this, you are finding out many things. So, one is the plan, and then these are the actions, and then again some plan actions like this. But ultimately, when you are basically coming down to that level, when there is no further decomposition is required. So, this one, if you clearly observe, there are three important aspects. First one is that goal to the individual operation level. Three other important aspects is, one is plan, define the ways subordinate tasks are carried out. So, if I say fill tanker with Cl2 is the primary main task, then plan that how the subordinate task will be carried out to do this main task. Then there is stopping rule, stop redescribing when it add no further useful information. So, you should not like park tanker and check documents, is it required further decomposition? It does not require. So, you do not do this. Where you find that yes, it require further and redescribing because it adds value in the operation, then you go on doing it. And third one is numbering. So, then what is task analysis? This is our hierarchical task analysis, because we started with the ultimate goal, and then finally we break down to the individual operation level, and in between what happen when you are interested to do this when you are starting with this overall goal, then you are planning that how that overall task will be completed, and then again the subtask, if it requires to further redescribing, then you have done this. In this manner you are coming to the bottom level when no further redescription is needed, because you are at the actual execution and operation level. So, an HTA usually descends to 4 to 5 levels. When we in 4-5 levels, it will be covered. This is hierarchical task analysis. There are other task analysis also, like tabular task analysis. So, usually we use hierarchical task analysis, and this is what is the approach. It ultimately gives you all the elemental tasks to be completed for the overall goal to achieve, and then at each of the elemental level you try to find out what are the error that can happen. Okay, so that is why this task analysis is important. Now let us see some of the techniques. So, you have seen earlier failure mode and effect analysis. The equivalence of failure mode and effect analysis in human error analysis is action error mode analysis. So, what happened? The analyst start with listing of individual actions. So, you have already seen when you have done the task analysis. So, task analysis gives you the bottom level actions, and then what happened? You just do those things that identify how each action can conceivably fail, means what way when you are doing that action. Suppose you are basically parking or looking at the documents, preparing the documents. So, what are the errors that you can make? So, then if you make error there, what are the causes that led to that error? Then identify the effect, then describe how the human error modes can be detected, then determine how critical this mode, then identify risk reducing actions or features. In FMEA, what you have done? You find out the failure modes, find out the effects, find out the detectability, then also the causes of that error failures and consequences of this failure, and how to reduce the risk of that failure modes. Exactly in the same manner, what happened? So, action description, close manual valve, suppose PV1 you do close, action error mode, close wrong valve, then action error cause may be procedure error, may be communication error, may be valve marking inadequate, may be lapse, and then action error consequences may lead to explosion, risk is very high, then there will be some risk reduction measure and some comments will be given. So, that means it is similar to failure mode and effect analysis, but please keep in mind that task analysis is the starting point here. Once you have broken the overall task to the elemental actions, then against each actions at the operation level, actual execution level. So, there can be different kinds of errors. So, what way we are identifying error here? What way the human can fail to do this elemental task. Okay, and then rest is like failure mode and effect analysis. And also you can add the criticality analysis. Now, human HAZOP. You know what is HAZOP, hazard and operability studies. What we have seen in HAZOP? We have identified the process parameters, then for every process parameters we have chosen effective guide words, and then using the guide word to process parameter you found out the deviations, and then those deviations are the important thing, because they talks about the deviation from the normal operating conditions, and then you want to find out the causes of that deviation, consequences of that deviation, and finally your this one recommendation for improvement. Now, in human HAZOP the same way, you have to the elemental task, or the elemental task by means the task which is not required to further described. So, at the bottom level task, and then at every bottom level task you find out that what are the guide words that is applicable for that task, and then find out the deviation that can take place, and find out the causes of those deviation, consequences of those deviation, and how the deviations can be removed. So, this is what is the worksheet. This is what is the worksheet given here, that action description, guide word, action, then action, what kind of error, and then what are the causes and consequences, like this. In FMEA what you have done, there you found out what way, what modes, and here you are finding out the deviation, more or less they are similar, but here we are basically using guide words. So, maybe more scientific way you can develop this. Okay. So, I don't want to discuss the objectives and steps further, because these are similar to HAZOP study what you have done earlier. Now, I will show you some of the guide words for human HAZOP, because the guide word will be different than the process HAZOP. You see that guide words here. Process HAZOP guide words, when we have discussed, we have more or less discussed these are the things. Now, human HAZOP guide words, no means not done, when a similar analogy, less, less than, more than, as well as, other than, repeated, sooner than, something like this, reverse, later than, misorders, part of, as it is part of. Okay. So, because it is the human work, so your guide words should match with the human work, the task human is performing, elemental task. So, that particular task, close the valve, it is not done. Okay. So, in case of HAZOP, basically when you are talking about valve, there we got the process parameters, maybe that flow, so no flow. So, here it is not done. So, then these are the basic guide words, some more basic guide words given here, no action, more action, less action, wrong action, part of action, extra action, other action, more time, less time. So, different guide words are given. So, my request to all of you, just do one human HAZOP test study using this guide word. What you have to do? You do the HTA task analysis, find out the elemental task. At every elemental task, you see that what are the guide words applicable, find out the deviations, and then follow the normal HAZOP table. Okay. Now, we will discuss something which is little higher than or more popular in human reliability analysis, the systematic human error reduction and prediction approach, that is known as SHERPA. This was developed by Embre in 1986. Embre 1986. So, we will see one case study using this also. So, we will spend some time here. What are the objectives? Objective, identify all human errors, action errors related to the study object, their causes and consequences. So, that means we will show SHERPA has given, in SHERPA we see that some of the error types, actually what happened during execution of the task. Assess the probability and severity of the error, identify possible recovery actions that may prevent the error from leading to significant consequences, decide whether actions are required to control the hazards, and if so, to identify ways in which the problem can be solved, make operators aware of the hazard related to various actions. So, these are the objectives. Now, you will find out what are the typical worksheet will be like this. First is action description, then what is the error, then what are the causes, what are the consequences, whether recovery is possible or not, probability, severity, actions, and then comments. Okay. So, let us see that what are the different error types used in SHERPA, and we will also show you one case study that we have done using SHERPA technique. But we will not describe the everything about the case, whatever needed for today's topic, human error identification, that part we will describe now. SHERPA taxonomy, error taxonomy has action error, checking error, information retrieval error, communication error, selection error. So, 5 types. Again, under action errors, so these many 10 different errors are given. Under checking error 6, under retrieval error 3, communication error 3, and selection error 2. So, it is more or less sufficient. So, when you see any task people are doing, elemental task, you will find out that the error will fit to either one or more of the different types. So, under action error, operation too long, too short, operation mistimed, operation in wrong direction, operation too little, much, too much, misalignment error, right operation in wrong objects, wrong operation on right object, operation omitted, operation incomplete, wrong operation on wrong object. Checking error, check omitted, check incomplete, right check on wrong object, wrong check on right object, check mistime, wrong check on wrong object. Information retrieval, information not obtained, wrong information obtained, information retrieval incomplete. Information not communicated, wrong information communicated, information communication incomplete, these are under communication error. Selection error, selection is not done, wrong selection done. So, that is selection omitted and wrong selection omitted. So, that means 10 plus 6 26 plus 3 29 32 34 34 different error modes. Okay. So, if you try to do human error analysis for your workplace, people work for the job, then I think these 34 error modes that really helps you, and now we will show you how this can be used in a real case. So, we have done a operation study on overhead and gantry cranes. So, let me read out this. Overhead and gantry cranes are machineries used worldwide for lifting and transfer of heavy loads in industries and ports. So, for this study, operation of 2 gantry cranes and 2 EOT cranes are considered, and the overall process, how the crane operates, what are the different stages of operation, and what are the ultimate elemental tasks, we will discuss in the next slide. But you all know that crane basically take the load, transfer load from one place to another, and unload in some other place at the unloading point. And again, during loading there will be lot of elemental task, transfer time elemental task, and also when the unloading time elemental task will be there. And these are basically done by that operator will be there and helper will be there, and the facility under which the crane is operated, that is also important, because its facility design may lead to safety and related problems, and as well as because of this there can be human error, or other way human error also can lead to safety problem. So, here load transfer using overhead and gantry crane, that is what we are showing here. Okay. So, first is pre-startup inspection, start the crane, load hardware, move the hardware to desired position, unload hardware. So, that means what is the overall goal? Overall goal, load will be transferred from one place to another. So, then immediately what you are doing? You are basically planning. So, plan, then what do you do? First is inspection, start, then load the hardware, move hardware from one place to the desired place, and then unload hardware. So, in sequence you have to do. So, do in order. Then 1, 2, 3, 4, 5. Now, again what are the pre-startup inspection? By saying pre-startup, is it clear? It is not clear, because you have to is to be inspected, that is important. Then it is further broken down: inspect lower part, inspect top part, inspect lifting accessories and load capacity. Now, if you say no, inspect lower part, there are many parts. So, then you have to further break into 1.1.1, 1.1.2 like this. So, that means ultimately decomposing the overall task to subtask, subtasks to elemental task. Okay. So, we have done this. So, that means here 1, 2, 3, here, then here 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So, like this 14 elemental task prepare. Now, again as I told you that inspect the, let me go back, inspect the lower part. This one further broken down, you see how many? 1, 2, 3, 4, 5, 6. So, if I say this is the main task, overall task, these are the sub task, this is sub task, then this is elemental task. If we do not further break down these two lower level. So, at the lower level I am telling the elemental task. Okay. So, in this manner what happened? The entire elemental tasks, total elemental tasks were computed. So, error number, then task type, error mode. Now, then what we have done basically, for every elemental task like 1.1.1, 1.1.1 check tracks for obstacle and or damage. Then check tracks for obstacle and damage omitted, incomplete. This check is omitted or check is incomplete. So, it is basically checking error, either omitted or incomplete. So, from the SHERPA, the taxonomy, you know the task, you know the error mode from the SHERPA taxonomy, and from task analysis you know the task, you compare the two. How many that error modes, out of the 34 error modes, how many are applicable for this particular elemental task, and then accordingly you write. So, either it will be checking error, or it will be retrieval error, or it will be inspection error, or it will be action error, or it will be selection error. Then error, consequence, recovery, whether no recovery possible or not possible. We have written no recovery. So, that is what we have understood, and then we asked the people who were working there and the supervisors, engineers, and based on group discussions we have identified all those consequences. First we have done the task analysis, and with the help of them we verified that. Then we also shown them, train them with the error modes, SHERPA error modes, then a group meeting, and finally things were developed. So, it is required for human error identification. You see that all those errors are, it is basically we have given 1.3.3. So, just a minute. So, 1.3.3 pre-startup inspection, this one we have shown, but if you see that ultimately there are 1, 2, 3, 4, 5 subtasks. So, under 1 again 1.1 inspect end power, 1.2 inspect top part, in then 1.3 inspect lifting accessories. This we have that 1.1, 1.2, 1.3, this we have further described and finally gone to elemental task to represent in this lecture or to present in this lecture. And other things also we have done, and it is available in this literature, Mondal et al. The detailed analysis up to quantification, it is available in this literature. Okay. Now, I will show you that you can go through this book Kirwan, a practical guide to human error analysis. In Appendix 2, they have given different errors. In Appendix 2.1, they have given the generic errors, some generic errors like general rate for errors involving very high stress level, like your error in simple routine operation, and their probability level also they have given. So, they have not only described the errors, they have given what is the probability of obtaining having that errors. So, you may go through. I am not reading out these things, but I have listed here just to tell you that there are resources available. It is a fantastic book, wonderful book for human reliability analysis. Then they have given some operational error in plant in Appendix 2, like your control error, like your precision error, like that welder worked in on the wrong line. So, several 16 different errors are given. So, then some ergonomic experiments was conducted by them, and then also there also they have put some of the errors from ergonomic experiments, typing performance, human recall performance, something like this. And then they have also developed some simulator, and from there also particularly for nuclear control room operations point of view, they identified simulation, they developed simulator, and from there they have identified different kinds of errors. Okay. So, 7 different types of errors are given. And in fact, in this book I have just the Appendix 2 I have shown here, not the full Appendix 2, and just only the error types or error modes, in fact error modes, not error types, error modes. And he has given, Kirwan has given example against each of the error modes there in this Appendix 2, and the probability of happening such errors also given. So, it is much more, and the entire book is very lucidly explained, and you all who are interested in human reliability analysis may go through this book, that will help you. Okay. So, finally, I will show you the references what we have basically gone through. In my last 2 lecture, I told you that this reason human error was main book, and today I think that for SHERPA this Embry, this is a very good material. Then Kirwan 1994, it is for overall human reliability analysis and understanding many of the techniques, it is very good book. Komamoto and Henley also given one good chapter on human reliability analysis, and the case study I have shown a part of this paper, which is basically our paper. So, I hope that you got some information today which will help you in practically doing human error analysis, particularly in identifying the human errors. So, the analysis part will come soon, and we will show you some of the more techniques and then quantification of human error. Thank you very much.